Welcome to 8th lecture from chapter number 9. We are studying VLSI design, and today we'll study clocked CMOS logic. Before this we have been studying static CMOS. Clocked CMOS is a kind of dynamic CMOS logic. What's the difference between a static and a dynamic logic gate? A static gate, the output of a static gate is valid as long as the input is valid, like we have in case of CMOS, not NAND, NOR, and any Boolean expression that we implement using regular CMOS. The output is valid unless the input is valid. If we remove the input, the output will also be no more. But for a dynamic case, even if you apply input, there is a clock. The output is valid only if we have a clock is equal to 1. If the clock is present, the output is valid, and if the clock is not present, even if the input is present, the output isn't valid. The block diagram of a C2 MOS clocked CMOS circuit is given here. We have this regular PMOS array connected to VDD from the top. The inputs are applied here. You have regular NMOS array connected to the ground. From its bottom, the inputs are applied, but we have two additional transistors, this and this. The PMOS transistor, to which we apply the complement of phi. Phi is clock. Phi is clock. If clock moves like this, on and off, if this is phi, the complement of phi is its 1's complement, means the output is the naught of phi, right? So we have this phi bar applied here, this phi applied here. When this phi bar is a 0, this means this PMOS is on, and when this phi bar is 0, phi is a 1. This means this NMOS is also on. So if phi is 1, phi bar is 0, this gate is enabled. Whatever we apply at input, the proportional output will be the Boolean output would be available at this terminal, the output terminal. And if we have phi is equal to a 1, phi is equal to a 1, this one, sorry, we have a phi bar is equal to a 1 and phi is equal to 0. This NMOS and this PMOS, they both will be off. The output will not be valid even if we apply the inputs. This is the block diagram of a clocked CMOS circuit, right? Implementing regular CMOS circuits, implementing clocked versions of regular CMOS circuits is very simple. Like we are gonna implement a C2MOS NAND 2 here, right? The regular PMOS array for NAND 2 is this. We already know, and we have implemented it a number of times. A and B are the inputs, this VDD. And the regular NMOS array is this. We know that. A, B, connected to ground. And in between, we have these clocking transistors. This PMOS transistor, whose input is phi bar. The NMOS transistor, whose input is phi. And we're gonna have the output from this terminal. So while we have implemented this, there is a small homework for students. Students are required to implement C2MOS NOR 2. Right, before we conclude this lecture, we are going to solve another example. We are going to implement a Boolean expression with the help of a C2MOS, the C2MOS version of this Boolean expression. This is an example. F is A and B or C in parentheses plus means or x dot y, x and y, and the whole expression is inverted. So we know that the precedence of this AND operation is more than the precedence of this OR, and the precedence of this AND is also larger than the precedence of this OR. So we'll put on these parentheses ourselves. Right. To implement PMOS array, we know we have to apply De Morgan's law. So to apply De Morgan's law, we'll have this A dot B or C dot x dot y. Right. So we have distributed this inversion but have replaced this operation with its dual, or operation was replaced with its dual, which is AND. And then further distribute this bar A like this, and then the last step is distribute this bar, apply De Morgan's law once again, right. Now we have the inversion distributed over each and every variable. And now we are ready to implement PMOS array. The PMOS array says we have to first implement this B and C, then ORed with A, and then ANDed with this OR. So X and Y OR, and then ANDed with this whole expression. And here we'll have the clocking transistors 5 bar 5, and then beneath this we'll implement the NMOS array. And we know that to implement NMOS array we just implement its naught, that is F naught is A dot B or C whole or x dot y. Right, we'll implement this, the inversion or the complement of this, that is F bar. So B or C, and then B or C ANDed with A, and then ORed with this AND. So X and Y ANDed together, and then this whole stuff will be connected here, and we'll get our output F from here. So we have implemented a number of Boolean expressions with the help of clocked CMOS logic. We will continue studying more dynamic circuits in our upcoming lectures. Thank you.